Chapter 6 Permutations, Combinations, NCERT Exercise 6.3. This is first theorem. The number of permutations of n different objects taken R at a time is NPR. Theorem 2. The number of permutations of n different objects taken R at a time, when repetitions are allowed, n power R. You can do it with boxes, right? There are n boxes. Like that. There are n boxes. In first box, you can put n. You will have n minus 1 things. You can select 1 out of n minus 1 things and put it here. You can select 1 out of n minus 2 things and put it here. You can select 1 from n minus 3 things and put it here. So n times n minus 1 times n minus 2 times n minus 3 and goes on. That is NPR, factorial n. NPR means factorial n divided by factorial n minus r. N times n minus 1 times n minus 2 times n minus r plus 1. N minus r minus 1. That means n minus r plus 1. This is the formula. That is called NPR. Suppose repetitions are allowed, every box can be filled with all n things. So it will be n times n times n times up to r, n power r. Now let's go to the example 1. Find the number of 4-letter words with or without meaning which can be formed out of the letters of the word rose, where the repetition of letters is not allowed. So it is NPR. NPR means 4P4. We are selecting 4 things out of 4. 4P4. Factorial 4, the factorial 4 minus 4, that is 0. Factorial 4 is answer. But here repetitions are not allowed. If repetitions are allowed, it will become 4 power 4. There are other theorems which are very important. You can just read. The number of permutations of n objects, where p objects are of one kind and rest are all different, then factorial n by factorial p. Theorem 4. The number of permutations of n objects, where p1 objects are of one kind, p2 of second kind, p3 of third kind, pk of kth kind, and the rest are different, if any are different, then the answer will be factorial n by factorial p1, factorial p2, factorial pk. You have to put that factorial of repeated words. Find number of permutations of letters of the word alphabet. There are 9 letters here. Allah, 2, Haba, another 4, 8, D, 9. There are 9 letters. A, repeated 4 times. 1, 2, 3, 4. 4 A's are there. L's, 2 L's. So number of permutations will be according to this theorem. Factorial 9 by factorial 4 times factorial 2. The answer is this. We use calculator, but you don't use calculator. I am using calculator here. How many 4-digit numbers can be formed by using digits 1 to 9 when repetitions are not allowed? So there are 1 to 9 letters, and we have to select 4 and permute them. Permute means make arrangements with them. That is factorial 9 by factorial 9 minus 4, 3024 ways. 9p4 ways, 9p4 ways. Example 11. How many numbers lying between 100 and 1000 can be formed with the digits 0, 1, 2, 3, 4, 5? There are 6 letters here. When repetitions are not allowed. So 3-digit numbers. How many numbers lying between 100 and 1000? Between 100 and 1000 there are only 3-digit numbers. So I put 3 boxes here. There are actually 6. First box can be filled in 5 ways only because we cannot put 0 here. So it is 5 ways. Second box, you can put any number, select any number. But this time one number will be missing. That is 5 ways. Third, you can put in 4 ways. Because one more number is missing here out of 6. One number is put in this place, means there will be 5 numbers. One number is fixed in this, means there will be 4. 5 ways, 5 ways, 4 ways. This 5 because 0 is neglected here in the first place. So 5 times 5 times 4 is the answer. 100. Find n such that NP5 equal to 42 NP3. Second, NP4 by n minus 1 P4. NP5 means NP5 equal to 42 NP3. Given that NP5 is 42 NP3. What is NP5? Factorial n by factorial n minus 5. 42 times factorial n by factorial n minus 3. You simplify. See, factorial n and factorial n gets cancelled. Here, factorial n gets cancelled. Here, factorial n minus 5 is cancelled with this. So, take into account only remaining number, and you will get n minus 3 times n minus 4 is 42, and you will get a quadratic equation here. You will get n is minus 3 or 10. Minus 3 in permutations and combinations, we don't use minus numbers. So we are taking n equal to 10 as a correct answer. Secondly, NP4 by n minus P4 is 5 by 3 here. So what is NP4? Factorial n by factorial n minus 4. What is n minus 1 P4? N minus 1 minus 4 by n minus 1. This is reversed. This is in the denominator, right? So it gets reversed. And the whole thing is equal to 5 by 3. On simplification, you will get n by n minus 4 is 5 by 3 and n is 10 again. Let's go up. Example 30. Find R if 5 times 4 PR is 6 times 5 PR is the same thing. You just expand this into this form, cancel out the things, and you will get the answer. You will get a quadratic equation in R's. And R is 8 or 3. 8 does not fit because this R is always less than this number. Here you cannot put 4P8 is wrong. So 4P3 is correct. 5P3, 5P2. 5P2 is correct. So we are neglecting this, we are taking this. That's correct answer. Example 14. Find the number of different 8-letter arrangements that can be made from letters of the word daughter so that all vowels occur together. All vowels should occur together means make all vowels into a single entity. A, U, E, these are the vowels. These are the vowels. Put a sign like this. This means A, U, E. So how many things? 6 objects will be there, including this. We are removing 3 vowels from 8 things, 5 things plus this star. This, what is this star? This is the single entity of all these things. So actually you will not break your head on this issue. So there are 6 objects altogether. These can be arranged in factorial 6 ways. That's correct. For every arrangement, these vowels A, U, E can be arranged in factorial 3 ways. So the answer is this. Example 15. In how many ways 4 red, 3 yellow, 2 green discs can be arranged in a row if the discs of the same color are indistinguishable? That means all 3 yellow balls are same type, 4 red are same type, 2 green are same type. That is the meaning of this. Or indistinguishable. Nobody can distinguish between one green ball and another green ball. They are lookalikes, same thing. So we have got 4 plus 3 plus 2, how many? 9. So factorial 9 by repetitions, no? According to the theorem number 3, we are putting this under the denominator. 1260 is the answer. Find the number of arrangements of the word independence. In how many of these arrangements do the words start with P? Do all vowels never occur together? Do words begin with I and end in P? There are 4 sub-questions. All are attended here. There is no problem. If you read, you will understand. There are 12 letters here. Independence, 12 letters. And there are 3 N's, 4 E's, 2 D's. So total number of arrangement of 12 letters, taking 12 all at a time, will be factorial 12 divided by repetitions. These things. These things. This one, and this one. Factorial 3, factorial 4, factorial 2. Now, coming to sub-questions, for words to start with P, so from all those 12 words, 12 letters, remove P. Put it in the first place. And remaining can be arranged in this 1,38,600 words. They start, all these words start with P because we removed P and arranged the remaining 11 letters. For words in which all vowels occur together, make all the vowels in one object. There are 5 vowels. 5 becomes one object, remaining 7 plus 1, 8. There will be 8 objects. The 8 objects can be arranged in factorial 8 divided by repeated how many? Factorial 3, factorial 4 won't come here because 4 is a vowel. Factorial 4 is not coming here because that corresponds to vowel E. That becomes separate entity. And for every one of these arrangements, these many arrangements, for every single one of these arrangements, this I, E, E, all the 5 words can be arranged in factorial 5 by factorial 4 ways because E is repeated 4 times. I am putting factorial 4 here. So final answer will be factorial 8 by factorial 3, factorial 2, this one, multiplied by this one. 3. The number of arrangements where the vowels never come together is total number. First one, the total number, 16,63,200 minus where all vowels come together. If you subtract that number, you will get the words where number of arrangements where vowels never come together. That is this answer. Now, fourth one. I should be first letter, P should be last letter. Fix I and P at extreme ends. So you have 10 letters left. Same thing. Factorial 10 by factorial 4, factorial 3, factorial 2. That is the answer. With this, examples are completed. That has become a long video. And exercise 6.3 begins. 6.3 will be done in my next video. Thank you for watching this video. Please subscribe.